is now multiplying radicals. Guess what we do tomorrow? Divide them. Yes, you're very smart. So we're going to divide radical expressions when you come back to class tomorrow. And then you get a quiz on Monday. So your quiz on Monday, you're going to simplify, add, subtract, multiply, and divide radical expressions. I just made it earlier today. It is 12 questions, 12 problems. There are variables in some of them, not in all of them. So today's topic, like I said, is multiplying radicals. Before we jump on into it, let's just kind of review a little bit about what you've done with radicals so far in this chapter, and then I wanted you to review a little bit about FOIL and the distributive property within the context of number 4 and number 5. So I'd like you to go ahead and take a few minutes to respond to those questions for me. Here are your answers to your warm-up. I did circle them for you. Oh, the independent practice conclusion. You can use those to study for your quiz over the weekend. All right, so take a moment, eyeball that warm up a little bit. Looks really good. What's up, Gio? You could definitely do that. You could rationalize the denominator. You could. I feel like that's a lot more work. So I just did the quotient rule and I divided 48 by 12. That's 4. Square root of 4 is 2. There are several ways you could do that problem, honest to goodness, Gio. So if you wanted to rationalize the denominator and then simplify the resulting radical on top and then reduce out the bottom, that's fine. Some people today in class, throughout the 3 sections, I saw people taking the square root of 48 and breaking that apart, and then the square root of 12 and breaking that apart. It ends up, you reduce out that square root of 3 factor that appears in the numerator and denominator, and then they reduce the coefficients. So I've seen that problem done a couple of different ways today, but by far the fastest way to do that problem is to use the quotient property. Cool with that? Same thing with number 3. I saw that problem done in several different ways today, but by far the fastest is just to use that quotient property, divide out your 24 by 3, that gives you 8. Square root of 8 is 2 root 2. Questions about that? We're good? Okay, awesome. So let's proceed with multiplying radical expressions. So, excuse me. If you take a look at example 1, you're going to see more or less 2 styles of problems in this course. You're going to see just a radical expression multiplied into another radical expression that's made of multiple terms, and then you're going to see binomials that you have to FOIL. So we basically use two properties when we multiply radical expressions. The first one is the product property, and the second one is the distributive property. We utilize both of those properties to get through today's lesson. So let's start out with part A. Square root of 3 is hanging outside of a set of parentheses. Like, what do you all want to do with that right now? Jenna, go ahead nice and loud. Distribute, well said. So we are going to do that. And I usually take baby steps when I do this, so I don't make any mistakes. I'm going to go ahead and multiply the square root of 3 times 4 root 2. And then I bring down my minus, and then I have the square root of 3 times the square root of 12. And then I would use my product property as promised. So I'm allowed to multiply the 3 times the 2, because they're both underneath a radical that has the same index. So we have 4 square roots of 6. And then my second term, I'll bring down my minus. 3 times 12, that's 36. So I have 4 square roots of 6 minus 6. Those are not like radicals, so we are done. Questions about that? Remember, you always want to ask yourself, where did that 6 come from? Or where did the square root of 6 come from? Those are the questions you should ask yourself as you review each example. If you don't understand, you need to ask. Okay, this guy over here, part B, I see a binomial times a binomial. That means we FOIL, yes. So I'm going to take the square root of 5 times the square root of 5. That is going to be the square root of 25, which is 5. Outers and inners. So our outers is going to be the square root of 5 times 2. We're not allowed to multiply those together necessarily with a product property per se. This is just going to be 2 root 5. My inners, I have negative 5 times the square root of 5. That's negative 5 root 5. And then your last, negative 5 times 2. That's negative 10. Remember, when you FOIL, the last step is to do f plus o plus I plus l. So that's what we're going to do. F plus o plus I plus l. So we do 5 plus 2 root 5 minus 5 root 5 minus 10. And then I combine my like terms. So I'm going to go ahead and put my constants together. And then my radical expressions together. I guess they're all constants. Say integers is a better word, huh? So 5 and negative 10, negative 5, 2 root 5 minus 5 root 5 minus 3 root 5. Questions about that? Because it was a 2-hour delay day, I kind of like looked around in my period 4 class and it looked like they had a good handle on A and B. So I cut out C and D and I let them cut to some independent practice. I should share with you the fact that problems that I don't do with you in class, especially on a day like today when we're rushed, you have a quiz on Monday. So it's nice to kind of try those as a little bit of, studying. It's not like you have a review guide for this really short quiz. It's just 12 problems. You're going to have to simplify, add, subtract, multiply, and divide some rational or radical expressions. Rationals. Let's call it algebra. So yeah, if I don't do a problem, hey, that's like a nice problem for you to try before you take your quiz on Monday. Yeah, so you want to take a minute to check yourself. Looks like you're doing a really nice job. Ooh, moving on to the letters. Looks right so far. Does anybody have any questions for the class about this one? Anybody need me personally? Alrighty. Want to try something with letters? Yeah, let's see how it goes. Thanks for the reinforcement, Kevin. Much appreciated. All right, so in example 2, we are asked to evaluate each of the following, and we are allowed to assume all variables are positive. If I have time, I'll show you why that phrase keeps popping up. Once again, what is your immediate impulse, your reaction with regard to taking care of part A? What do you think? I heard you. What'd you say, Danielle? Oh, I thought you did. Oh, it was you. Yes, distributive property. Is that what you would have said, Danielle? Distribute? Yeah, okay. So we're going to go ahead and do the square root of 3x times 4 square roots of 2x. And then we exercise our product property, right? So you have 4 times the square root of 6x squared. Bring down your minus, and then we have to do the square root of 3x times the square root of 12. Using our product property on that guy, we get the square root of 36x. But you'll notice that both of these radicals can be simplified. So we have to go a little bit further. We always leave our answers in simplified radical form. So if you take a look at the first term, I have 4 times the square root of 6x squared. What do you think, Gio? An x does come out very good because the square root of x squared is indeed x. 2 goes into 2 one time. So that's the first radical expression. And how would I simplify the second radical? Square root of 36x. Any ideas? Yeah, it would. Question we have to, oh, Bailey. No, because the square root of x squared is just x. There's nothing, there's no remainder. Bailey, just a little side scratch work. You don't have to write this down, but whoops. I wanted to write that and this. Okay, so square root of x squared. The question we ask ourselves, you know, there's like a little index of 2 there. We ask ourselves, how many times does 2 go into 2? It's 1 time. And then how many are remaining? There's none, so I don't need anything in the radicand. Does that make sense? Can I combine those to finish it up? You're all shaking your heads no. Good job. Yeah, you can't. They're not like radicals, so we're good. Part B. I think Noah was starting these. What'd you get? How'd you start this? You foiled. Okay. So let's do that. So your first is going to be the square root of 3x times the square root of 3. That is the square root of 9x. And you could simplify that right then and there. Square root of 9x, that's 3 root x. Outers, we have the square root of 3x times the square root of x. That is the square root of 3x squared. And just like the one Bailey was asking about, square root of x squared, that's just x. And then the square root of 3 we can't simplify, so that stays like that. Inners, you have negative 5 times the square root of x. That is just negative 5 root x. You can't multiply those together because they're not both underneath a radical. So one stays outside, one stays underneath. And then your last. Oop, I did that backwards. That's my last. I wonder if it'll let me move it. Oh, look at that. That is slick. Okay, so that should be my inners right there, right? Whoa. Negative 5 times the square root of 3 is negative 5 root 3. I hear chairs moving. It's usually my cue. Class is coming to an end. The last step that we go ahead and take care of in this particular problem, we go ahead and we combine our like terms, right? You have to take your f plus your o plus your I plus your l. So I usually take a minute and kind of look at it a little bit. I'm looking at this guy here. I'm like, oh, you know, like here's something with root x and here's something with root x. You can put those together. And then I'm going to look at these. And they both have the square root of 3, but can you combine them? No, very good. So this guy here, we get plus x root 3 minus 5 root 3. Your homework is the back, the paper you started yesterday. What's up, Megan? This right here? Oh, I'm so sorry. I heard beep. You can't put 5 and x together with subtraction. They're not like terms. Right. Yeah, they're not like terms. They have to have the same variable part. So I could add 5x and x together, but I can't add 5 and x. Yes, Jenna.